Good morning, everyone. Welcome to Chemistry 104. So in class on Tuesday, the last topic that we talked about was the idea of taking measurements and changing them into scientific notation. Remember that for scientific notation, this is a method that we utilize to express numbers that are really large or really small in a method that it illustrates the significant figures that the measurement has. And in addition to that, it actually also incorporates the quantity that the measurement has. So in order for us to review the concept of scientific notation, I'm going to do these two problems. That is problem 2 of the in-class worksheet. And let's get started with letter A. So problem 2A, okay? So utilizing number 1 for small, number 2 for large. What kind of measurement is in letter A? Is it small or large? 1 for small, 2 for large. Let's put it on the chat. Love to see those ones. Excellent. Okay. Now, utilizing a number, let's put on the chat, what is the number of significant figures in that measurement? Oh, you guys are going to kill that first exam. Great job. 3 sig figs is what we have there. So the 3 significant digits in this measurement are going to be these digits back here. Now, let me zoom in. Let's now know that since we have a small number, we have a written decimal place that we're going to move left to right. And in this case, this decimal place has to move such that my significant digits that are in my measurements are going to be at least 1, but less than 10. So in order to do that, we will move this 1, 2, 3, 4, 5, 6 places from left to right. When we do that, our measurement converts to the digits 1.85. Let me not forget of the unit of measurement, which is meters. Then next to that digit that I wrote 1.85, which is called a coefficient. Then we're going to do the time 10. Next, we are going to put those places that we move that decimal place as an exponent. And because this is a small number and we move left to right, this is going to be a negative exponent. So the answer is 1.85 times 10 to the negative 6. As you can see, my exponent, okay, represents the number of places, and my coefficient is going to have those desired 3 sig figs that are necessary in order to keep the resolution of my instrument still intact as I utilize this method to express my measurement, okay? Let me do one more. Let me do letter B. In letter B, we have 60.0, okay, seconds. Let's put on the chat, how many sig figs do I have in my measurement? Excellent job. Great job, you guys. Yes, the answer is 3 sig figs. So what does that mean? That the coefficient that I'm going to write here will have 3 sig figs. Now, in this measurement of 16.0 seconds, I only need to move my decimal place, in this instance, from right to left, only 1 time in order to now have the decimal place live right here. So when I write my coefficient, it's going to be 6.00. 6.00, those zeros after the decimal place, because they are after the first non-zero digit. No problem. Give me a moment. I will explain why this is 3 sig figs. Once I have moved that decimal place, again, those zeros are significant because there is a written decimal place, and those zeros are after a non-zero digit. So since the digit 6 is the first non-zero digit and the zeros are after it and there is a written decimal place, that's why they're 3 sig figs. Does that answer your question? So remember, zeros are significant if there is a written decimal place and if they are after a non-zero digit. Great, no problem. So in this instance, we move from right to left only 1 place. So if that happens, then we're going to do times 10. We only move 1 time to the 1. And since our movement was right to left, it's going to be positive. So, and let me include the unit. So the answer here is going to be 6.00 times 10 to the 1 seconds. Now, as practice, I will give you guys 2 minutes. Let's do specifically letter C, D, and E. So I'll give you guys 2 minutes. Let's do. That's a great question. Does the unit goes after or next to the coefficient? The way that I'm writing is going to be right after the times 10. So the unit is always going to be the last thing that you write when you're like writing a measurement. So you have digits, and then the last thing that you have is a letter to represent the unit. So I know it looks kind of like a 5, but trust me, that's an S representing the unit of second. One more minute. Put a 5 in the chat if you already finished all 3. I just want to see how many people are done. I have 55 students here today. Thank you for joining. Okay, so half of you guys finished. No problem. You still got a minute. Excellent. So the 2 minutes have passed. Let's now go over the answers for C, D, and E. So for letter C, this measurement already has digits that, if we think about the rules for coefficients, the coefficient is already set. So technically here, we don't need to move the decimal place. So what do we do in a case like this? Exactly what I'm just mentioning. Nothing. We don't have to move the decimal place. But this measurement can still be converted to scientific notation. So how do we do that? We write the numbers 6.7, because that is the measurement. We still do the times 10, but since there was no movement left or right of that decimal place, then I'm going to put a 0. Okay. Then I'm going to put the unit, which is grams. One of the things that you need to hopefully recall from previous math courses is that 10 to the 0 equals 1. So that's why we are able to do this. Go ahead, Lucas, unmute yourself.
Is there any reason that we wouldn't just leave it at 6.7 grams instead of adding the 10 to the 0?
That is a great question. So the reason why we still need to put the times 10 is to keep the consistency for scientific notation. So one of the things that we are going to do sequentially after we finish this topic and we speak a little bit about rounding is that we are going to be doing things in terms of math operations. And at times when you have numbers, you may want them to be all in scientific notation. It is a choice. I agree with you. Rarely you see that measurements like this are changed in scientific notation, but a scientist can adopt and change all of the measurements to scientific notation just because of the ease that it provides in mathematical operations that need to be performed for obtaining the data of a particular experiment.
Thank you.
No problem. Let's move on to letter D. In letter D, we have a small number. In this small number, we can see that there's a written decimal place. We have to move it in this direction, left to right. So we're going to go 1, 2, 3, 4 times from left to right. Now, our measurement has 4 sig figs. So 5.010 is going to be our coefficient. We're going to do times 10, negative because we move left to right, 4 because we move 4 places. And lastly, we put the unit, mg, for milligrams, okay? Any questions about letter D? Just put an N if you don't have a question. No, there you go. Awesome. Let's go through letter E, which is the last one. On letter E, as you can see, this is considered a large number because in terms of quantity, we are having a measurement that it is in the, that has digits, I should say, in the hundreds place. So when this is occurring, we are going to be moving our decimal place from right to left. In this measurement, we're going to be moving it 1, 2 times. So we moved it 2 places. Our measurement to begin with has 4 sig figs. We need to keep them in the coefficient. So this is 4.500 times 10 to the 2. And the measurement is seconds. Okay. Questions about letter E? Great. Put a 1 in the chat if you understand scientific notation and you're ready to move on to the next topic. Awesome. The next topic that we have in chapter 2 is going to be rounding. okay? And rounding is something that we are going to utilize specifically when we move on to the concept of using significant figures in mathematical operations. And in the laboratory, I hope we get to do one-on-one the lab for measurements, because it's so important that you guys are able to understand how to do measurements, how to do mathematical operations in sig figs. But one of the things is that we need to remember how to do rounding. Now, as you can see, I have rounding rules on the left side of the slide. Basically, this is just making sure that you remember that if you are trying to round to a set number of significant figures, you need to look at the digit next to the last sig fig that you're counting. And if it's 5 or more, okay, you're going to add 1. If it's less than 5, okay, you don't do anything to that last sig fig. And there may be times that all of those digits just turn zeros. It's just a rule of thumb. So let's go over some of these problems that we have on the right side of the slide. So I'm going to do the first one with you guys, and then we're going to proceed to practice with the other 3. So in the first problem, it says that we need to take the measurement 10.253 meters, and we need to round it to 3 significant figures. So when I look at this measurement, I have to tell myself, well, based on the rules that I know for significant figures, it's important to know that I'm going to look at those digits starting left to right, because that's how we read numbers in English. So this number is significant. This number is significant. This number is significant. So that means that the last digit technically is going to be that 2. Now, according to rounding rules, then I'm going to pay attention to what is next door. Next door, I have a 5. So because 5 is next to that 2, then in rounding rules means that that 2 will be converting to a 3, okay? So when I round that original measurement to 3 sig figs, the number that I will be reporting is going to be 10.3 meters, okay? And understand that the application of this, we're going to see in the next concept, which is how to deal with sig figs when I'm doing mathematical operations. So let's right now practice, okay? Let's do at least the number 2 and number 3. Let me just number them so you guys see. So I already did number 1. Let's assume that this is number 2. Let's assume that this number 3, and this is the 4th one. So I want you guys to work on 2 and 3. I'll give you guys a minute. Let's find the answers for when we round the measurement 25.01 kilograms to 1 significant figure. And let's find the answer when we round the measurement 204.7 milliseconds to 3 significant figures. I'll give you guys a minute. Okay, let's go over the two problems. So the problem that I designated as number 2, when we round 25.01 kilograms to one significant figure, let's put on the chat what will be the answer. Let me see you guys' answers. Okay, I see some correct answers here. So for my students that answer 30, kilograms, that's correct. So the reason why we need to include the 0 after the 3, remember that if we do a number line, let me just make notes a little bit below. Let's say that we have a number line. We have the values of 20, 25, and 30. In terms of quantity, 25 has a digit in the 10th place and a digit in the ones place. The 10th place digit is going to be the value of 2, in other words, 20. The digit that we have on the ones place is the 5, right? So when we're rounding, remember that last rule that it says here, that everything after is a 0, okay? Now, it applies here. Because in this instance, once we look at this digit as our one significant figure when we go left to right, and we proceed to say, okay, next to it I have a 5, I agree. The 5 will take the 2 to a 3, but it will convert to a 0 because when we look at the quantity, that 2 is sitting in a 10th place. So we need to turn that 25 into 30. Put a 1 in the chat if that makes sense for the students that didn't write 30 in the chat. So be careful with those. So when we're rounding, it's not only, adding 1 or leaving it alone. We also have to pay attention to the quantity that we start with, okay? Let's move on to number 3. On number 3, we're rounding to 3 significant figures, the measurement 204.7 milliseconds. So when that occurs, let's understand that my 3 significant figures will be the digit 2, the digit 0, the digit 4. Who's next door to that 4 is a 7. So that means that 4 is going to turn into a 5. And then the answer for that is going to be excellent. 205 milliseconds. Okay? Great job, you guys. Questions about rounding? Yes or no? We're good with rounding. Excellent. Since there are no questions about rounding, let's move on to the next topic, which is, okay, so now I know that significant figures are basically these numbers that are actually extracted from the resolution, meaning the digits that carry meaning when I'm doing measurements in the laboratory and I have a particular instrument. That being said, as I really hope you guys experience next week on Tuesday or Thursday when we're taking measurements, there's going to be times that you're going to take measurements and then you're going to be doing some mathematical operations that include addition and subtraction, multiplication and division, or a combo of all four of them. And that can also include parentheses at times, exponents at times. So there's going to be a variety of ways in which we take measurements, and then we have to do mathematical operations in order to get a particular result based on what we're measuring. So we have rules of how you express your significant figures if you're doing different mathematical operations. To be honest with you, when it comes to these, I think that students sometimes forget the ones for addition and subtraction. That's the one that just it's not as clear at times. So let's define what's going to be the difference of how, if I have measurements and I do these operations, addition and subtraction or multiplication and division, how do I determine my final answer? So as you can see illustrated on the slide, when we are doing addition or subtraction, let me highlight it for you. The final answer is written so it has the same number of decimal places as the measurement with the fewest decimal places. So the name of the game for addition and subtraction is decimal places. That's what I'm paying attention to. What are the decimal places that my measurement has? And then if I have a measurement that has the least number of decimal places, my answer needs to be rounded to show that. You may be asking yourself, but why people need to do all of that? Remember that measurements are attached to resolution. And when it comes to this, then you can actually say, okay, I have to make sure that my measurements take into account that I have or I utilize an instrument that maybe the resolution is not as good. So instead of saying, oh, I use the best instrument that have the most resolution, remember that a resolution means that if you have a lot of digits, you have a higher resolution. So you need to account for that maybe in some instance you utilize something that maybe didn't have as much resolution. So that's why the measurement, if you're taking them and you have to add them or subtract them, it has to have the least number of decimal places. So that final answer represents that you might have used an instrument that doesn't have as good as a resolution. So you can see here that we have three different measurements. We don't have units here. We only have the digits, but let's actually just write down what is given to us. So the first set of digits have 3 decimal places. The second set of digits has 2 decimal places. The last one has 1 decimal place. As you can see, calculators do not know sig figs. Calculators are just a tool that if you put digits, is going to output specifically the numbers that the screen can hold. So understand that when it comes to this, your calculator display is not your final answer. The calculator display for adding 2.012, 61.09, and 3.0 will illustrate that the answer of that is 66.102. Now, because let's assume that this is measurements and you need to express it in the correct number of sig figs, we need to round to the correct number of sig figs. That in this case, it's represented by the fewest decimal places that I have in my measurement. So when I round my answer, it needs to be, as you can see, to the 10th place. In other words, 1 decimal place. I mentioned this because at times students are like, oh, but you just have to look at sig figs. Let's hold on a minute. For addition and subtraction, we're looking at decimal places. So you go through your measurements, the one with the least number of decimal places, that's the number of decimal places that you are going to round to. So that being said, I'm going to jump. Lucas, do you have a question?
Yeah, I was gonna quickly ask. I don't know if you're gonna cover this, but what if you had like a number like 600 where it was only significant with the six, and you got an answer? Would you round to the hundreds place? Like it will only be 600 or 700 or whatever?
That's a great question. So in a case like that, if we have a measurement among the one that we took that is a whole number, then you round your final answer to the whole number. Because at
Meaning
that
if it,
point, it's not really the hundreds. Well, it depends on what you're doing with the operation, right? But if you are adding or subtracting, depending on what you're doing, it's not so much that you will be rounding to the hundreds place. What you're going to be doing is leaving it as a whole number. Let me give you an example on the little corner here. Let's say that we have 587. You have 413.1. You have 2.57, right? You are overall going to be, let's say, subtracting these digits from each other, right? So if you go to your calculator and you enter 587 minus 413.1 minus 2.57, what did people get? Let's put it in the chat. Make sure that you have your calculator handy. Excellent. That's what I also got. So you're subtracting all of those digits, right? So you get 171.33. When you round this, you're going to be rounding. Actually, let me just change this to 500. So it's not in the hundreds place. That'll be make it. So if I do that, this will be your answer from your calculator display. You don't have a position in the hundreds place, right? Just because of the operation that you did. But because overall, when we look at the number, this has 0 decimal places. So decimal places, my shorthand for it is DP. This has 1 decimal place. This has 2 decimal places. I need to round that to no decimal places.
Professor?
Yes.
What I was asking was more if like one of the numbers were like 500, and it was only like that the 5 was significant and the 2 trailing zeros weren't significant. Then would you round it to be either 500 or 600 or 400 or something like that in that case?
Okay, I see your question. So remember that when we are adding and subtracting, we are not looking at the measurement and looking at the significant digits that it has. We're looking at the decimal places that they contained. So if you had a number that has trailing zeros, like you just said, 500, you're not looking at it from the point of view of, oh, that's only 1/6. No, I'm looking at the digit 500 as that has no decimal places. So when I subtract, add, or whatever, is going to be no decimal places shown. The rule for addition and subtraction is that we look at decimal places, not at the significant figures in the measurement. Does that make sense?
A little.
So this is what I mean when it comes to addition and subtraction. In addition and subtraction, let me just finish this problem right here. When it comes to this, let's put in the chat. What is the final answer when I round 71.33? Great job, you guys. My final answer here is going to be 71. So going back to the question, let me just do a little problem here. So your question is, what if I have a measurement that is, let's say 400, right? Let's say 400 centimeters. I measure that. And then let's say that I'm going to add another 2.5, or let me just change that number. Let's do 4.75 centimeters to it. So this is the type of question that you're asking, Lucas, correct? How do I handle adding these two? Okay. Because I'm adding, I need to look at these measurements in terms of decimal places. The reason why I do this is because my operation, my mathematical operation, is dictating how I'm going to treat these measurements. Are we good so far? So the addition tells me that I'm going to treat these measurements by looking at their decimal places. So that's what's directing the show. Am I adding or am I subtracting? Are we good up to that point? Great. So since what's directing the show is my mathematical operation, even though you will be like, well, 400 has only one sig fig, hold on, I'm adding that number. So what I'm looking overall is saying this has 0 decimal places. This has 2 decimal places. Sorry that my markings are blending in. So when I add these two numbers, even though my calculator display will say 404.75, my final answer here is going to be 405, a number that has 0 decimal places, because I am adding. I hope that helped. Because we need to understand that these rules are not absolute. We have to look at the situation that we're confronted with. So we take measurements and then we have to say, okay, once I do my measurements, what do I do with those numbers? Do I need to add them, subtract them? So remember, your operation will tell you how we're going to be treating those measurements in order to round to the correct answer, okay? Let's do a little bit of practice. I think that will at least help. So these problems are in slide 16. So if you want to move on to slide 16. And I want you guys to try problems 1 and 2. Let's do problems 1 and 2. In number 1, we're adding. In number 2, we're subtracting. So I'll give you guys 2 minutes. When I write my answers for these two problems, understand that I'm going to do the calculator display. And I'm also going to show what is the final answer. Remember, for 1 and 2, because we're adding and subtracting, the name of the game is going to be look at decimal places. Okay, so I'll give you guys 2 minutes to finish these. Excellent. Let's go over these two problems. So when we look at the two measurements that we have here, the digits that have been given to us are 25.6, which has one decimal place, and then 36.27, which has two decimal places. It says that we're going to add them. 25.6 plus 36.27. Okay. I get a calculator display that it is 61.87. Put a 1 in the chat if you got that. How many decimal places do I need to have in my final answer? Great, 1 decimal place. Excellent job, you guys. This, the first one, you need to round to 1 decimal place. So when we take 61.87 and we round it, okay, to 1 decimal place, what number do we get? Great job, 61.9. Lucas, the question that you have on the chat, I'll answer it during break. I'll go over it during break, the one that you posted. Let's go over the next one. I have 1.337 minus 87.5128. We actually get a negative number. I got negative 86.1758. Put a 2 in the chat. Is that what you got? So we get a negative number. Now, when we look at our digits, the first one has 3 decimal places. The second one has 4 decimal places. Let me give you guys a disclaimer, which is a rule that sometimes students come up with that I don't know where it comes from. When it comes to these problems, you will not see that the digit that has the fewest decimal places will always come first. That's not a rule. You actually have to go through all your measurements and see where are the digits, okay? So please do not assume that on the left side of an equation or of a series of digits that you have to add, you will always find the one that has the fewest decimal places. You actually have to look through all of the stuff that you have. So when it comes to this, my final answer needs to be rounded to 3 decimal places, okay? So when I round this to 3 decimal places, sorry, this is going to be kind of tight. It's going to be negative 86.176. Put a 3 in the chat if that is what you got. Great. Questions about just doing addition and subtraction by itself and significant figures? How do we determine that answer? Any questions? Yes or no? Oh, I saw somebody had a yes. Question?
Hey, Dr. Lewis, I just
Yes,
had a
go ahead, Andy.
question about kind of like how the question was worded. So it told us to calculate the answers to the appropriate number of significant figures.
Uh-huh.
But we're using decimal places. So oh, and I saw that the 1.337 has 4
Mm-hmm.
significant figures. So and then the second one has six significant figures. So how do you know what's the appropriate number of significant figures?
That is a great question about of how problems are worded in chemistry. So whenever you have mathematical operations, you're going to be prompted to determine the appropriate number of significant figures. Because at the end of the day, you're talking about digits and you're talking about resolution, and resolution is attached to sig figs. Now, you need to register in your brain that whenever the question is worded this way, all I want you to do is apply the rules for mathematical operations for significant figures. And based on what I showed you right now, if you're adding or subtracting, decimal places is what determines your final answer with the correct number of sig figs. It is just a way that we word it in chemistry. You will see in many instances, I'm not going to give you problems. And this includes in the exam that I say, oh, in the following problem, write your final answers with the correct number of decimal places. I don't word the stuff like that because even in the textbook, it is worded similarly, that you're going to show significant figures going from the idea that mathematical operations are going to determine how you look at these digits, and for addition and subtraction is going to be decimal places that will tell you the numbers and digits that you have at the end, which are in essence the significant figures. So it's just a way that we word it in many disciplines, including chemistry. So don't be confused by saying, oh, it says sig figs, but then if I look at sig figs. So let's just, take a moment right here so I can show you guys, or at least verbalize the journey that you guys have gone so far in this course. In this course so far, you guys learned the definition of chemistry, you learn measurements, you learn units, and then I told you that when we take measurements, they have a resolution. That illustration of digits is what we call significant figures. And then understand that where we at right now, our stopping point is those numbers we are going to actually add or subtract. It is better illustrated in the lab that we're going to do next week, and I really hope that we get to do it. And based on that, we have rules for those operations. It happens to be that in those operations for addition and subtraction, it is going to be decimal places. But overall, that is going to show us the final answer, that it is the digits that carry meaning, which in chemistry we call significant figures. I hope that answered your question. It's just the way that we word it in order to prompt you to do the correct operation, to treat these numbers based on the mathematical operation that you're directed to do. Great. So I think this is a good stopping point, family. Right now is 9:33. Let's actually take a break to 9:45. I'm going to stop the recording.